In the last video, I implemented a system timer using a versatile interface adapter, or VIA. And one of the things with that VIA is that I can set up a timer on it and have it basically count down from a value that I provide. And basically every time it counts down and it hits 0 in that countdown value, it will throw an interrupt. And then in that interrupt, I was just checking and keeping track of how many times that interrupt had happened. And after 9 times, I was then updating this daily clock value that's in the BIOS data area. And ideally, I want to update that BIOS data area, the clock counter that's in that at address 40:6C. Ideally, I want to update that every 18.2 times per second instead of every 18.4 times per second. Tom Story on my YouTube channel had a nice comment, a simple adjustment. And previously what I was doing is I was loading up a value of where I wanted that countdown timer on the VIA to start counting from. And the maximum value is FFFF. So there's a high byte, low byte. So I've got a word that I can count down, and I was setting it to FFFF. And that was still too fast for 18.2 times per second. So I was then keeping track up in this other timer interrupt and comparing every time I got into this interrupt from the VIA, I was counting and just tracking it. And after basically 9 iterations through that, then I would actually do the updating of this clock counter variable, which is in the BIOS data area. His suggestion was, well, maybe instead of looking for 9, look for 10 loops, and then bring down the actual value of the timer. Don't set it to FFFF on the VIA, set it to a number so that when you have 10 of them, does match up to 18.2 times per second. So that's what I've done. I've gone in here and I'm now setting my VIA1 timer to hex EC18. Well, EC18 is the same as 6440. And basically the way to come up with this 6440 is this 5.4945 times P clock divided by 1,000. Or if you want to back up further than that, I can take 1 over my P clock, which would be the 11 megahertz, so 11 million, multiply that by my VIA timer, VIA1 timer value, whatever this is. So that's kind of the question mark in the equation. And that gives me a 5.94. I have to multiply that times 10, which I'm going to put into this variable here for now, this EQU. And that would get me to 54.945. And basically, it was getting me close to this 55 milliseconds that I'm looking for. But anyways, if I take all of that and I just simplify it down to this, here's a simple little formula now that if I can just take 5.4945 times my P clock, in other words, 11 million divided by 1,000, that's a value I'm going to put into this VIA1 timer. And so I've just pre-calculated that for if I'm running an 11 megahertz P clock, a 10 megahertz, or an 8 megahertz. So that's the processor, actually it's peripheral clock on my system, but that's the same speed as the internal processor runs, and it's half the speed of the system clock. So for my 11 megahertz P clock, or 22 megahertz crystal I have on the system, that is EC18. So I've got that dialed in, and this should be pretty close now to this 18.2 times per second. So I set these here. I jump over here in my initialization for the timer, and I'm going to load up that hex value from over here, EC18, and that's going to be the countdown value for the timer. And then in the actual interrupt, I'm going to check and see if it's made it to 10 loops. And once it's made it to 10 times that loop, then I actually go ahead and update my clock counter. I just mark it up 1. And that's just going to keep updating every, 55 milliseconds. That's going to go ahead and update. And so that is updated and should be pretty close now at this point to this desired value of 55 milliseconds. So Tom, thanks for that comment. Simple implementation change here to dial that in from 18.2 to 18.4 times per second. Something else I've done is I have implemented write support for my IDE interface so that I can now write to my CF card. And basically it's interrupt 13, which provides the disk services. And what I've done is I've come in and added a write sectors function. So it's function 43 of interrupt 13. And as a reminder, I have a bunch of different functions I support for disk at the moment, and this isn't all of them that I'll eventually have to support. But I am using, on my FreeDOS, I do have it set to use LBA. So on boot up, it's going to use LBA even if it doesn't need to. And when I am using LBA, what I find is FreeDOS makes a call and says, do you support these extensions? And I'm returning that yes, I do. And then it would use this function 42 to read. It would use function 48 to read the drive params. And I tried to do a write before I implemented the write function, and my log output told me that it was looking for this function 43. So I came in and added a function 43. And in that function 43, I'm basically coming in here and I'm taking in what drive. I only have one drive, so it's drive 80, which is my C drive. And then DSSI needs to point to what's called a DAP. And if I go up to my read, I put some documentation in for the DAP. So that's a disk address packet. Basically, it's a structure that has a bunch of information in it. So it has this size of the packet is the first thing in there. It's always set to 10. And then it has, at the next offset within that structure, it has an unused byte that's always set to 00. But then there's a block count. Then there is a destination buffer location. And then there's a start location in LBA, so this logical block addressing. And so I need to fill in this data packet before I would call this interrupt if I was going to call it. Now, when FreeDOS calls it, though, it fills all this in for me, of course, and it just makes the call, passing a pointer to that structure. And so on the write, I have to bring in, I'll receive a pointer to that structure that I can work with. And the code for the write is pretty similar to the read code I had above it in the disk function 42. And really some of the only differences or changes I had to make is when I get down here, there's what command I'm going to run. And the read, I believe, was a 20. So if I go up to the read, that is a function 20. When I get down to the write, that is a function 30. So that's one change I had to make, is just tell it a different function number. And then instead of reading in from the CF card, I need to write out to the CF card. So that means that I'm now using this out SW. Now I did note when I was reading up on it, this website says not to use this out SW. Don't use this rep out SW. Instead, do your manual loop because there needs to be some delay after every write. And I assume that is based on a faster processor or faster system than I am using. And maybe that doesn't, well, I think it does apply to PIO mode, which is what I'm using because that's what this article is about. But long story short, you can see that I'm not following that advice yet. So I am just calling this repeat of this out SW for however many times I need to read information. And so I previously set up a loop that says you need to read 256 words times however many sectors the request is. So if I request from FreeDOS 1 sector of data, it's going to come in here and read 256 words from my memory and get it written out to the disk. Or if it's a read, it's the reverse, of course, read it from the disk into memory. And so with the out SW, I just had to make sure I filled in the parameters, slightly differently. So I had to make sure I filled in DSSI, which is used by out SW. And that's just simply pointing to, what is it that I'm going to be reading from, so that I can write it out to that CF card. So I put this in, I made those changes and put that into my system. And amazingly, it worked on my first testing of it, which there was plenty of room for things to go wrong there. So I was a little surprised it worked first time that I wrote that code and put it in. So that's great. And along the way then, as I was using the system, at that point, testing just some writes within my FreeDOS, I did notice that the date and timestamps it was putting on directories and files was incorrect. So one other thing I did prior to this video then, since the last video, is I did go in and I reworked or updated, I should say, some of the real-time clock calls. So there are calls to read the counter, set the counter. And so that's that daily counter that my via interrupt is essentially kicking off the update of this read counter. But there's also an interrupt, so you can call interrupt 1A and function 0 and get the current value of that counter. You can call function 1 and update that counter, which again is updating this memory in the BIOS data area. And then I have functions for read time, read date, set date. And I found that I had a couple of glitches in the read date, set date. So I fixed those. They were just minor little updates that I needed to make. And then I also updated my boot up process on the system so that my LCD on the motherboard, on the system board, will show me current date, current time, and temperature still. So it'll show me those three things on that screen every time the system boots up. And then I did tests in FreeDOS with the date command, the time command. I could set time, I could read back the time would persist even when the system was reset or turned off. So at this point, I'll go ahead and fire up the system. And on the LCD on the system board, you'll notice that it is showing the current date, time, and temperature. That information is all coming from the real-time clock. And from FreeDOS, now I can access my real-time clock with things like the date command that shows me the current date, and I can change it if I'd like. I can run the time command and see the current time and set the time. If I run it again, you'll see that the time has elapsed, both seconds and partial seconds, so that all looks to be working. I can also come in here and do a directory like I've been doing up to this point. And you'll notice that there's a temp directory there. And I'm going to go ahead and change into that temp directory. And just as a reminder, the first time I do a directory, it caches something, and that takes a little bit longer. So there's where that delay is. But I'm going to change into the temp folder, and I can do a directory there. I can now make a directory. So if I want to make a directory called test1, I can go ahead and do that. And it has come back successfully, or I think. So let's do a directory, and there's that test1. And with that test1, it is showing the current date, 6/13, June 13th, and 12:11 a.m. So that all looks good. And if I want, I'll maybe change into the test1 folder. And again, I can do a directory from there, but I might copy from the C drive. There's an FD auto file. I'm just going to copy any files that match that. And it looks like it copied 2 files. And so if I do a directory now, it's showing me the directory of that folder. And I can see it copied those files over fine. And it looks like it retained all the metadata, date, etc. for those files. So far, so good. Maybe one thing I would want to be able to do at some point is maybe use like copycon. I still don't have edit working. I have more work before I can get that working. But it would be nice to say copy from the console to a text file. And then at this point, I should be able to say, hello there. And I should be able to hit Control C to break out of that and have it save. And for some reason, I'm getting a copy failed, and I don't know what's yet causing that. And so that's something else I might have to dig into later. But that's where I would expect there to be now a file called readme.txt. But I am doing copies and make directories, and all of that seems to be fine. So if I copy star.bat to star.old, and it found one file, that's right. I do a directory, and now I've got that old file in there. So at this point, I now have some cleaned up real-time clock functionality. And I have added write support, and I am successfully writing to the CF card on my IDE interface here. So next step, I need to order up an updated, well, first of all, update the PCB and then order the updated PCB for this IDE interface. I was waiting to make sure that IDE writes were going to work before I ordered the PCB. And this PCB has a whole lot of bodge wires on the back of it because I changed the design after initially ordering it. So I'm going to go ahead and get that updated. I am also going to change around the physical connections a little bit. I'm using this sideways adapter for a CF card just so that I can easily plug things in and out, because the current headers are up top, which means these little adapters would point down. And so it's very difficult, obviously, to pull out the card if it's pointing down. So I'm going to move these headers down on this card, flip this around 180 degrees so that I can just pop these cards in and out through the top. Small updates, but every one of these small updates is making some nice improvements on the system.